Hello, good morning. Welcome to my stream. It's been a few days since I had a chance to stream, mostly because I was away for the holidays. And now it's time to dive right back into it and take a look, finish up anyway, our work on Advent of Code. So I'm way behind on Advent of Code. Obviously, I haven't been able to. I never finished day 22. And our calendar shows we got part 1 of day 22, but we didn't get the rest of the days. And so my stats are going to be pretty ugly with this 24-hour business, but that's right. It's all about the fun, not about the stats, right? So let's take a look at day 22. And actually, I did talk to a friend of mine gave me a hint on day 22 to consider, instead of doing on and off for the regions, to do additive and subtractive. Is that a word? Basically a positive versus a negative cube, and think of it that way. And that made a lot of sense to me. I think it consolidated a few things in my mind about how it was supposed to work, or the approach to try to use, and it also makes it a lot easier to think about the I keep saying cubes, but they're regions, because in order to create a subtraction region, you just have to do an intersection. And what I was trying to do was create, I don't know, however many possible intersections of cubes. Remember all of this stuff from my last stream. And the approach that I'm thinking of now just requires a simple intersection, which is easy to calculate. So, I mean, I believe it's easy to calculate. Remember, what we're trying to do is try to have this. It's called a reactor, and the reactor has a number of regions in it which would turn on and off. This one has an on region, this one has an off region, and so on. And each region is basically just a volume of a rectangular prism with X, Y, and Z coordinates, and we have to figure out what volume is left on after we apply all of these operations. So instead of doing all of this crazy stuff, I'm just going to delete all of this. I think this is checked in, right? Oh, it isn't. What did I do here then? The last thing I did was, part 1, and then we tried to work on part 2. I'm going to just add this git commit bad day 22 part 2, and then what we'll do is oh no, it's not source main, day 22 mod. Okay, so I think, yeah, we're going to just blow away all of this stuff for regions and just create new ways of doing regions instead of all this join stuff. Let's delete all of this. I think we want to keep overlaps, but we're going to simplify the overlaps. Because the overlaps is like I have here in the comment, just a simple, oops, what am I doing? Here, just a simple check instead of all of this check. So we're going to simplify that as well. And let me delete all this here. We don't need that anymore. So if we just create a region that can turn on or off each itself, then we should be able to create a a list of commands which enable us to intersect cubes and intersect regions. Oh, I commented out all of the... Oh, this, yeah, so this was going to be for part 2, and then the small was going to be for part 1, right? Then we had some tests. I don't know if the tests still work. All right. We have 2 warnings, but that's probably because we're not using this join or remove. So let's actually delete these guys too. We don't need any of this. All right. We're creating a reactor. What's gonna be the reactor? We're gonna have reactor is a vector of regions. So what we can do is every time we have a region, which is down here, we'll do an insert or remove, like we have here. And for the reactor, here's the region code, and the reactor code is going to have an insert, and it's going to insert on itself. So we need a mutable reference to self, and we're going to add a region to it. Like this, and then we can have a remove, which does the same thing. Be self, which removes a region. And so this is just my skeleton of what I'm thinking of doing. And when we insert something, if we have 2 overlapping regions, we want to add a 3rd region which will have a negative effect. So the 2 regions we're adding will have a positive effect, and then we're going to subtract out the intersection. So we do need to write a little bit of code up in the region section here, which generates an intersection of 2 different regions. Intersect. And it's just going to take a self and an other, and it's going to return an option, because if they don't overlap, there's nothing to return. So if we say if self overlaps other, then just return none. So that's pretty simple. And then to create a new, we're going to have to create a sum of an intersection. And I think this is really simple, because we have just x min is going to be, just visualizing it, it's going to be the max of the 2 mins, right? So self min x min dot max of other x min, right? Or it could be the other way around. Either way. And we're just trying to get the max of the 2 mins, and then x max is going to be the min of the maxes. Right, and then we'll do the same thing for y and z. Yep, this should be z and z. This is z and z, and this is y and y. And then that creates the region that intersects the 2 regions. And the idea now is to say, if we have an intersection, then we want to have a negative effect on it. So our reactors, if we're doing an insert, we want to first loop over all of or maybe I shouldn't call this R. I don't want to call it new. This is what we're adding, and this is what we're removing. So what we want to do is want to loop over each region before we add it, and determine whether or not we're going to make it a positive region or a negative region. Oh, in which case we actually need to make this a little more complicated, right? Because we need a little tag on each region to say whether or not it's an additive region or a subtractive region, whichever you want to call it. So instead of a vec of regions, how are we going to do this? We're going to create an enum, which is going to say positive or negative. And that'll be the type of region we create. And then we're going to create a struct called something, which is going to take, we can have a region, and it's going to have a command or type, charge. There we go. Oh, I didn't give this a name. Type. I don't want to call it type. Type has got too much overloading. Well, let's call this a charge. Sure. Region, charge. And then instead of being a struct of these, we'll call it a struct of energy. Because we can have positive and negative energy, I guess. So the idea is now we'll create each region in the reactor will have its extent, right? Its XYZ definition, and then whether or not it's a positive one or a negative one. And then we'll just call this a reactor. And then we'll call this a reactor. So if let, right. So if we're returning option, let's split this here real quick, because what we're returning here for the intersection is option regions. So I was thinking we should do an intersection here, right? If let sum intersect, what we're doing is looping for the one we're adding. We're going to say, does any region in our reactor currently intersect, I think I spelled it right, with the one we're adding? So r dot region dot intersect with add. So if this returns not none, then we have a region, and it could be a positive region or a negative region, right? You can have a new region that's entirely inside a negative region. So we say if, let's say r dot charge is equal to positive. If it's a positive region, then we want to create a new flip with the negative region. So we'll say, and now we're going to need to add an additional, so on top of the ones we already have. So we'll just say update is vec new. And then what we'll do is we'll extend, after we create our additional intersections, we'll just extend our self. So we'll say update.push and a new energy of the intersection, and the command is going to be the opposite of, right, so if we have an overlap, we're going to create a negative region, else the charge is negative, so we're going to push intersect with a positive. And when we flip back and forth like that, and then we just say self.reactor.extend with update. Do that. Okay. So that's an insert. Oh, and then we have to actually add the new one, self, reactor, push. And this is going to be, we're inserting a new section, so it's going to be energy of add and positive. Right. So with the remove, we're going to do the same exact thing, except we're not going to add it at the end. Because we're removing a section, we're going to just intersect the negative region and generate the negative region here. Oop, not here, here. Because if we intersect a positive region with a negative region, we just generate the negative cube and we're done. If we intersect a negative region with a negative region, then we want to flip it back to positive because it must have had a positive before from the previous region. So actually what I'm going to do is I'm going to change this to process, and then I'm going to change this to be insert region, and we're going to just call self process add, and then push it, and then remove is just going to be self process remove, and that's all it needs to do. And I don't know if this is going to compile. Let's see. It doesn't like energy. Oh, I misspelled it. E-N-E-R-G-Y. Oh, right, it's charge positive. Okay. Same for that, and same for this. And it doesn't like this. Oh, reactor doesn't have region, it just has a reactor. That's right, I changed the name of that. And now we can't compare them against each other. So we'll derive partial equal. Oh, why did I say CMD? It's charge. Region and charge. My brain is broken. Okay. Doesn't like this. Oh, it found a region. Oh, I'll have to clone it here. Oh, and I put a semicolon down here. And now I can't do this. So I'll have to create a new region to insert. So let's take a look. Let's see, R, we have R here. So I can just insert R, right? And then remove R. Expected region, found region. I'm gonna hit F1 again. Oh, and now we have a different, yeah, so this is for part one. We don't want to call this a reactor anymore. Oh, this is, right, we need a part one and a part two, because part one is just yeah, actually this is wrong, right? We want to check everything. If it overlaps, we still want to turn it on, but I guess we got part one correct anyway. Except it said to ignore anything outside. So what I want to do for part one, I can still use the old way of doing it with the hash set. And what we can do is say we don't need R is small anymore for this guy. But for the part 1 we do. So we can say part 1 and part 1, and instead of saying join and remove, we'll just do a no, I have it backwards. This is part 1 here. And this is part 2, and we don't want to check to see if it's small. And this is going to be insert and remove, like that. And now we don't have a len. We need to calculate the volume for the reactor, and that's part 2. And part 1 is just going to be part 1 len. Okay, and I'm going to shift this over here because we're going to do this XYZ thing again, which I had before, but I broke. XYZ. And we're going to change xmin and xmax to be xmin dot, we're trying to look for negative 50 to positive 50. And we'll do the same thing for here and here. And we'll just say max negative 50 and max negative 50. I think that will allow us to continue working with part 1. And we'll see. Oops, what do I do? Control D. Oh, right. This is called part 1 now. And we don't have volume. Okay, so volume should be straightforward, right? Because we're going to just add up all the volumes of each So what we can do is create for a region, we can create a volume, which will get this the volume of a single region. There we go. And it'll just return an I64. And it's just going to be self x max minus self x min plus 1. And what are these? They're I64s, so we're all good. We don't have to cast them into I64s. Times, and then we do y and z, and we're done. So y, z and y. So that's the volume of that thing, and now we need a volume for reactor, which is going to be, we loop over every entry volume itself, I64, and we're going to say for R in region, self reactor, each one of these is a region, and if it's a R dot charge, if it's positive, then we can charge dot positive, we can say it's the volume of we're gonna add this to a total. Let total equals 0, total plus equals, and if it's negative, total minus equals. Okay, and then we just return the total. And doesn't like this. Why not? Oh, can't move. Okay, so we can just ampersand that and ampersand that. Okay, so we still have 2 warnings. Oh, we're not using is small anymore. Okay, that's fair. Yep. Okay, and that takes care of that. And we already downloaded the test data, and it should be in here somewhere. Where are we reading it? Input test day 22. Okay, so last inputs test day 22, and it's just this. Oh, yeah, we need the second test. We need this bigger test. We do have test 2, which is going to be the longer one. Yeah, okay, and then we'll get an answer here, and we'll see how close we are. All right, so we're going to change this to test 2. And I have to do it here because I got to specify the day. I got to fix my main to run day 22 if I want to run it inside my thing. Well, it came up with the wrong answer, so that means there's a little bit of debugging to work on. That's okay. I think we're close. But it was it went pretty quickly, considering the size of the region. Right? We came up with a huge number. But let's figure out what could have gone wrong. I'm looking over the process function here now just to see. Create a new vector. We loop over the reactor entries, the regions in the reactor. If it intersects, then we want to create a negative charge if it's positive. If what we're adding, oh, yeah, and then we update it here, so we didn't forget that part. And then we push a new version of it here. Removing it is just the opposite, except we don't add a negative cube. And then when we total things up, yeah, I don't let's see if the first one, does this have any? No, that doesn't overlap. That doesn't overlap either. And this doesn't overlap either. So I can't use the first test to see where the overlaps are. What we can do actually is use the smaller example on with the new code and see if that at least works, and that'll allow us to print out the results as we find them. Because it's very small, so we'll be able to see it should come up with the same number, 590784. Oh, yeah, and that was wrong too, wasn't it? 474140. Oh, right, because we're running the... Oh, here we are. Yeah, 47414. Okay, so that part was still correct. But what we'll do is we'll use the reactor code instead of this code here for the first test and see. Yeah. So for input test, let's call it test 3 because I'm going to strip out the extra sections. Test day 22 to inputs test 3 day 22. End bin. There we go. So I'm just going to delete these guys, so it should come up with the same number. So run. There we go. Yeah, we're not using part 1. Okay, so it came up with 0. So okay, so there's our. Let's debug that, and it should be pretty easy to debug. What are we can do? Source day 22. Okay. So as we add entries here, we'll just print them out. Println creating negative for this, and I'm gonna have to derive debug for intercept, and this is going to be creating positive, and then we're going to say adding this, and this will be removing. And actually what I'll do is I'll just tab this over so that we have a little space for it, and then I think I'm going to need to derive for region. Yeah, these are region. I have to derive debug so I can print them. Not found in the scope. Oh. Okay. We have 2 warnings, but because we're not using part 1. So let's take a look at what the output is here. All right, so we added negative 26, blah, 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 blah. And then, so this overlapped right away. So this region goes to 33, but our overlap goes to 26. That's right. Huh. Y-min is negative 36, but our Y-min here is negative 20. I would have thought it would have been negative 21. How is that off by 1? Y-max is 23. I would have thought it would be 17. Did I get this all wrong? What did I do? Oh. I forgot to change these. Y and Y, oops. Y and Z. Okay. Let's run that. And was that the answer? No, we're still getting 0. Let's look at the top now. Okay, so 20 to 26 is right. Negative 21 to 17, yeah. And then negative 26 to 7. That's right. That's right. And then we added another region, negative 22, and now we're going to actually compare it to all 3 of these. So we have a negative 22 to 28, which is in this range here. Oh, it's in this range too. And so we do need another negative region here. But somehow it's all coming up at, oh, I know why it's saying 0. Because this should be reactor volume. That's why that was 0. Okay, let's try one more time. Did I get it right? Where's the first example? Nope. Okay, so here's where the bug is, right? After executing these steps and ignoring these things, We should have gotten 590784. And we're not. I see. Oh, why is this flipping back and forth like this so much? I think this must. Oh no, it's the z-axis is changing. Okay. Let's do these four, and then see if we can take a look at how it's behaving there, because maybe that'll be an even simpler test. Inputs test 4, update 22. Let's just do that. And test 3, change to test 4, and what we can do is print out the volume after every step. And so now I'll just say kernel run 22, curve volume. All right, so turn on 27 cubes. 19 additional cubes turn on. That's correct, so that worked. The third step turns off cuboid, so turns off 8 cubes. So if we subtract 8 from that, we get that. And then final step turns on a single cube. So at the last, yeah, so 39 are on. So that's working. So let me, are all of these within the range? There's nothing that goes like 1 over or something. No. So this should end up being the same. This should work exactly the same. So if I change this back to test 3, let's take a look at the volumes as they change there. I don't know if that's going to help. Considering the cubes only within this region. Oh, wait, am I? Yeah. So this is a bug here because I'm saying, oh no, I said dot equals. Okay, yeah, all the way up to 50. So what we can do is compare the volumes, right? Because the volume should be the same. So we can keep doing this and then compare the difference. And maybe that'll show us where the bug is. Part 1.len. Oh, sometimes this happens. Okay. All right. Here's the first failure. Right, we're correct for the first 5, so it's the 6th command. 1, 2, 3, 4, 5, 6. But there's nothing special about this line, right? That I can see. But this might be where we start flipping back and forth, between doing that multiple entry thing. So let's do a less. Look for volume. That matches, that matches, that matches, that matches, that matches, and this fails. Okay. So it's this here where we're adding this to all the previous regions. What's special about this particular one? all the other ones have start on negative. So this is the first one where we have x all in the positive range. If we added regions where x max is 1, shouldn't these also end up being 1s? Because this is 2 to 47. Oh, this doesn't overlap. So, yeah, it doesn't overlap these last guys. It overlaps these guys here. So 2 to 7. And negative 22. It should be negative 6. Oh, that's probably this thing here, right? Negative 6 to 17 is in that region there. So there must be some others that have, yeah, so this guy here, for example. Yeah, so once we add this guy here, this is where it all falls apart. And the numbers are parsed correctly, right? Negative 22, 22, 47, and 2. Alright, let's keep digging. Maybe my overlaps code is bad. We can change it to what we have in the comment. So let's comment this out and just add this. So if self.xmin is less than or equal to other.xmin and xmax, and self.xmax is greater than or equal to other.xmin, and we do the same thing for y and z, z and y, and we don't need this extra at the end. Oh, what did I do? Okay, I just loaded it. Now we'll try again. I must have had a multiple suspended things here. Why isn't this commented out? Why are these red? I don't know. Self xmin less than or equal to other xmax, and self xmax greater than or equal to other xmin, and we'll do this again. Y and z, z and y, y and z, z and y. Okay. I don't know if that was the issue, but let's take a look. Oh. Yeah, that was it. What a wild stab in the dark that was. Okay, so now we're coming up with the correct answer. Who knew? Okay, so let's blow away the bad overlaps code. I don't know why that was bad, but it was. And let's get rid of all the other printlns because it's just wasteful output. And now, what we can do is create two different reactors. We can create a part 1 reactor and a part 2 reactor. We don't need this anymore. And we'll call it part 2. And what we can do is say for part 1, I'm just assuming it's going to work for part 2 now. Maybe I should check that first. I call this part 2. And we're going to comment this out. I was just going to strip everything out and just do it. But what we can do is just say if x min is greater than or equal to 50 and y min x max is less than or equal to 50 and y z y, then part 1, if switch is on, part 1 insert, else part 1 remove. And I'll just put this on one line because it fits. Oh, there we go. And change this. We don't need that anymore. Let's see if this even works. Error check. 2 warnings. Okay, let's just run it. Okay. That's obviously the wrong answer. Let's add, let's go back to this test input, which is test 2. Yeah, test 2. I'm still running test 3. Test 2. All right, is that the right answer? That looks right. Okay, so I think we're close. Just change this to input. And I got this answer. Is this right? 648681. Yes. Okay, so I'm going to assume that this is correct too. And I made the right assumption. Okay, so thank goodness we finally got day 22. Whoops. And that only took 50 minutes. Let's clean up this mistake here. We don't need the hash set anymore. And then any code I've commented out that we can get rid of. Yep, we don't need this code anymore. This was code we just used for double checking, so we don't need that. The test will pass, otherwise I'll strip those out. Oh, I forgot to save it. Let's try again. All the tests pass. And I didn't break anything. Nope. Okay. All right, so that's day 22 in the bag. Let's source and inputs. Commit day 22, part 2. All right, thank goodness. That was getting that to work on the 22nd was too much of a struggle for me, but once I got the hint, we should have negative and positive regions instead of trying to turn them on or off. That made a lot more sense, and it made the calculation easy because all we needed to do was do an intersection and then create the alternate charge region.